So today we have a pretty interesting problem, and this is basically just asking us to prove that x square plus y square by 4 is less than or equal to e to the power x plus y minus 2 for x and y greater than or equal to 0. So what we can do is we can just take the 4 to the other side. So we get x square plus y square less than or equal to 4 times e to the power x plus y, and then we can just separate the other exponent, which is minus 2. And if this inequality is true, then obviously this inequality is true, and we can just bring this thing in terms of x and y here, so we have a nice little constant left on the side. So then we'd have x square plus y square multiplied by e to the minus x minus y to be less than or equal to 4 e to the power minus 2. So now that we have this, what can we do? We can just find the minimum of the we can just find the minimum, I'm sorry, not the minimum, the maximum of this function, right? Because if the maximum is less than or equal to this amount, then we're pretty much done. Now we can just set up the function f of x comma y, which would be equal to e to the minus x minus y, x square plus y square. So now it's pretty clear that this will have to have a maximum when x and y are greater than or equal to 0, and that's because in the first quadrant, or that's when x and y are greater than or equal to 0, right? And this is not a realistic picture, I'm just drawing it. It's non-negative, so it's positive, and as x and y tend to infinity, the function tends to 0. So what that tells us is that we can just take the partial derivatives and then find the boundaries later. So this would just tell us that the partial derivative of f with respect to x would be equal to 2x minus x square minus y square, again multiplied by e to the power minus x minus y, right? Then similarly for y, we'd have uh, probably 2y minus x square minus y square e to the power minus x minus y, right? Now what we can do is we can just find the critical points, which is when these two are equal to 0. So e to the power some whatever is it's an exponent, so it can never be equal to 0. So we would just have 2x minus x square minus y square to be equal to 2y minus x square minus y square, right? And we want this to be equal to 0. So this obviously implies that x is equal to y, and therefore our two new inequalities, we can just bring this over here, and then we'd have 2x square minus 2x equal to 0, and then we'd have 2y square minus 2y equal to 0, right? We can just make the substitution. If it's looking a little bit weird, x is equal to y. So now that we have this, we can do just simple factoring. Same thing here. So clearly the only 2 points are 0, 0 and 1, 1, because x is equal to y, and in that case the critical points will be 0, 0 and then 1 comma 1. So now what we can do with this is we can just notice that obviously 0, 0 is not a candidate for the maximum point, because it's 0, and therefore 1 comma 1, this is our maximum point. So what this means is that on the x-axis, so again in the first quadrant, on the x-axis, we have f of x comma 0 to be equal to x square e to the minus x. This is just again checking, and we have the derivative of f with 0 comma x by x to be equal to 0. Now when does this happen? This is what we want, right? We want this rate of change when it's on the x-axis to be equal to 0. So obviously this would just mean, let's take the derivative x, this should be equal to, I'm sorry, dx, this should be equal to x square minus 2x multiplied by e to the power minus x, right? It's a good function. So then we just set this equal to 0, and like last time we'd obtain x, and then x minus 2 equal to 0, x is equal to 0, and x is equal to 2. So since they're on the y-axis, we have 2 0, since 0 0 is obviously not a maximum. So what this means is that the only points on the boundary of the quadrant would be 2 0, and you know, corollary 0 2. I hope I pronounced that right. But now we can just find this. This is, yeah. Now we can just find this function at our critical points 2 0 and 1 1. So the function at 1 comma 1 is equal to 2 by e square, and at 2 comma 0, right, it's a second one, it would just be equal to 4e minus square. And then notice that this is the same as, you know, 0 2 2 0, same thing. Now clearly we have 4e minus 2 you know, as bigger, minus 2, and we already know from the beginning that our position is in the first quadrant, right? So our search is pretty much over. So what that means is, since this is the maximum value, we have that our function, I should write it here, yeah, our function is less than or equal to 4 by e square, and our function is just this, right? It's just this. So we have e to the minus x minus y times x square plus y square less than or equal to 4e minus 2, and then we can just rearrange this to get x square plus y square by 4 is less than or equal to e to the minus 2 into, I guess I should just use the dot, into minus x minus y. So I'll just, rewrite this minus y, sorry, actually this should become x plus y since we're moving it, minus 2, and LHS is equal to RHS. Our inequality is pretty much proved. So there we have our thing. So actually pretty trivial problem, but it just required on one quick insight. And yeah, thanks for watching, and subscribe if you want to. So yeah.